Ladies and gentlemen, please remember to keep taking notes for the questions that you might have for our panelists, and be advised that the more questions you asked, there will be a gift at the end of the session for those who have participated. So your participation won't go unnoticed. And now, Ms. Monei, thank you.
We can wait for the presentation. While we are just waiting for my slides to come up, I think I'm actually super surprised by the two presentations, because actually, not necessarily surprised, it's like one of those moments when things work together. You would swear that they read, or they actually know exactly what I wanted to say in a way. I'm happy they laid a good foundation for what I'm about to speak about right now. So, my name is Nthati Monei, and I will take you through an interesting part of mining. I like what the two speakers mentioned. They mentioned that in mining, there's actually, so mining is done sustainably in this modern day, and we have different factors to look at. Dr. Barakos mentioned this T table. He said that you have your skills, and then you have your focus, and then particular skills that you need to have, right? So in mining, of course, there's exploration, excavation, everyone is happy about the mining. And then now comes an interesting part of it all, remediation. What do we do with the land that we had when we are done with our mining projects, basically? And this is where the diversity in professions in mining comes through. So I am focusing on phytoremediation in mining. And my specific area of focus is a country called Estonia in the north of Europe, so to say. And right. This is just a small geological map of Estonia. The deposits that I wanted us to focus on about is phosphorite deposits that they've got in Estonia, together with what we call black shale. Estonia is also an oil country. So, yes, now we can continue. So basically, these are the main resources that are mined in Estonia. There's oil shale, which acts as the main source of energy for Estonia and a few countries in the Baltic region. And then there's limestone, peat, clay, sand, gravel, and then phosphorite. The interesting part about phosphorite mining was that it was first initiated in the times of the Soviet Union. So at that time, the main interest was uranium. So they mined everything, and at that moment, so it was most for uranium and then phosphate production. And in 1991, when Estonia gained their independence, they thought, okay, now we seize all the phosphorite mining, mainly because of the environmental implications it had. And so in the end, you had these waste dumps that are found in an area called Mardulin. It's not far from the country capital, Tallinn. That's about 10 kilometers away from that. Right. So, about 73 million tons of black shale were removed off the surface and dumped somewhere else. Right? Now, I'll just take you through the properties of black shale. It's basically shale that's got, it's organic, but not enough to actually produce oil from. But what we get from it is mostly pyrite, and this can cause some leaching, and then in the end, you have also high sulfides in the soil. So the more these sulfides are, say, exposed to oxygen, you find that these actually ignite some fires. What happens then, you end up having, more ignition. So like, yesterday when we were going through the tour about Azerbaijan, it was mentioned that it's the land of fire. It's because of the oil. So if it's exposed to oxygen, that's what happens. You end up having these ignitions everywhere. And this is the same thing that happened with the mine dumps in Estonia. So, and then on the other side, you had some uranium that leached through to the water nearby. And so because of this, there has to be remediation methods that are applied to solve the issue that was done by mining years ago, so decades ago. And so they thought, okay, they could just plant some, they have some plants there and see, just to cover the land to prevent this. But that didn't work because this ignition still happened. So you had, like, this is the normal, what the shale would look like, but then after it had burnt, it looked like that. So that's what it was. And then here I am with my PhD. The proposal is phytoremediation, mainly because it's said to be cost effective, it needs less maintenance, and also is environmentally friendly. And so this is what phytoremediation is. In simple terms, it's basically using plants to remove heavy metals or toxicants from the soil in order to actually, so basically for remediation purposes. And in remediation, of course, you can have different methods that happen. What happens is that your plant in itself extracts all these minerals, or it can actually elements, or it can be organics as well, from the soil. So you can have this interaction of minerals with the plant roots, or you can have these elements also in the leaves. So what the plant does is that it absorbs everything and keeps it in its biomass, right? So I know my talk is rather more technical and, but it's the important part, right? So we have these mechanisms that we can focus on. When you're doing phytoremediation, the important thing is that you need to know, for example, what plant am I going to use? Where is it going to fit within, does it agree with the climate that you've got? The climatic conditions in Azerbaijan, for example, would be different to the ones in South Africa, to the ones in Estonia. So you need to find a plant species that adapts to that situation. And it should be able to extract and accumulate these metals, maybe within its body mass, so that you can have the plants there. And then in the end, you have to harvest the plants and put them somewhere, right? So because of the fact that we have to harvest the plant mass, somebody would ask, what do we do then with the plants? Because they still have the contaminant. So the novelty of my work is that these plants that can be used will also actually be used to produce biomass energy. So you see, this is a chain from thinking, let's solve an environmental problem, and also coming again to reduce carbon dioxide emissions in the country, because if they've got biomass energy, they lower the use of oil shale energy. And so, of course, then I'll have to find a suitable plant and to continue conducting phytoremediation, and then find ways in which we can fit this within the scope of bioenergy production. I picked 3 different plant species. I will not go deeper into the details of the properties of the plants, but we have Indian mustard, which is basically more prominent to growing in any region without being invasive, so it wouldn't interfere with the natural plants that you find in Estonia. Also, buckwheat is the same plant species that is grown there. It's actually normal buckwheat that can be used for food and also as a biomass energy plant. And then we will have these soils that were ignited, so the soil that actually was burnt up, and then the other ones that were not, just to see which one is more arable for the plants that we want to plant in the region. And so these are the main methods, of course, that we will go through. We have ICP-MS for elemental content within the soil and in the plants themselves, and then have some sequential extraction. And the interesting part is that while we are doing this, right, we can actually win rare earth elements, if at all we find them within the soil that we have. So in this process on its own, you have actually tackled phytoremediation, you have tackled the issue of, the contaminant issue, you are now solving energy issues, and then in the end you have some critical raw materials that you can find from the same soil, mainly using plants. And this basically proves to show me that mining generally is sustainable and can be done in many other ways. Some extract with, machines. I do it with plants. So by this, ladies and gentlemen, thank you so much for your attention.
Thank you very much. Thank you.